Today I am going to explain one of the most important machine learning algorithms called k-mean clustering. This algorithm is used when we want to group data automatically without giving labels. It is widely used in customer segmentation, recommendation systems and data analysis and also image compressions. By the end of this video, you will clearly understand how k-mean works and how it is implemented. What is clustering? Clustering simply means grouping similar data points together. For example, if we have customer data, we can group customers based on their behavior. If we have student marks, we can group students based on performance. Here the machine does not know the answer in advance. It finds patterns on its own. This is why k-means comes under unsupervised learning. What is k-means? K-means is an algorithm that divides the data into k number of clusters. Here, k means how many groups you want, means refers the average, which is called centroid. Main working idea of k-mean is very simple. Choose k centroids randomly and assign every data point to the nearest centroids. Move the centroid to the average of assigned points and repeat this process until the centroids stop moving. Once the centroids become stable, the model stops. Let's take a simple manual understanding. Suppose we take k equals to 2. That means we want only two groups. We randomly pick 2 points as centroids. Every other point checks which centroid is closer and joins the cluster. Then we calculate the average of each cluster and move the centroid. This keeps repeating until no further movement occurs. That is how k-means learns the grouping automatically. Now let's understand the Python code. Now I will explain the exact code step by step. First we import the required libraries from scikit-learn.cluster. Import k-mean. From scikit-learn.cluster, import k-means. This imports the k-means algorithm from scikit-learn. Next, we want to import numpys. Import numpy as np. This is used for numerical array handling. Next, we create our data set. Let's take a variable x. X equals to np dot array of Here we have 4 data points 1, 1, 2, 1, 4, 3, 5, 4. These can represent anything. For example, x-axis could be income, y-axis could be the spending behavior. Each row is an one data point. Now we create the k-means object. K-means equals to k-means of n clusters equals to 2. Random state equals to 0. Here n clusters equals to means we want two groups. Random state equals to 0 and choose the same result every time for consistency purpose. Now we train the model. This line runs the entire k-means algorithm internally. It chooses the centroid, assigns the clusters, updates centroids and repeats until the convergence. All the learning happens here. Now we print the output labels. This shows which data point belongs to which cluster. For example, output may look like labels zeros and ones. This means first 2 points belongs to the cluster 0 and last 2 points belongs to the cluster 1. Now we print the centroid values. Print centroids k-means dot cluster centers. This prints the final center of each cluster. These centroids are the average of the points inside each group. So now the machine clearly knows what the groups are, which point belongs where, and where the center of each group lies. This is how K-mean works practically in real project. Let's run this program. See, here we have the labels 1 and 0. First data points comes under the first cluster and second one comes under the first cluster. And both remaining 2 points are 0th cluster. Here are the centroid values 4.5, 3.5, 1.5 and 1. K-means is used in many real-world systems, customer segmentation in marketing, product recommendation systems, image compression, fraud detection, grouping student performance, medical data analysis, traffic pattern analysis. It is fast, simple and extremely powerful. Advantages and limitations of K-mean clustering. Here the advantages comes very simple to understand, very fast algorithm, works well for large data sets. But we have some limitations. You must choose the K beforehand, not good for irregular shaped clusters, sensitive to outliers. So final summary of this K-mean clustering is, K-mean is an unsupervised learning algorithm. It divides data into K groups. It works using centroid optimization. It is used in real-world AI systems everywhere. Thank you so much for watching this video till the end. I truly hope this explanation helped you clearly understand K-means clustering in a simple way. Stay curious and keep learning.